Defacto Technologies is an established design automation company since more than 20 years. Defacto has a worldwide presence with technical support 724 all over the world. Its design solutions are silicon proven and used by most of the top semiconductor companies in the world. Its flagship tool or set of tools is called SoC compiler. And this design solution helps creating large SoCs and providing full automation during the assembly process. With this design solution, not only RTL and gate level formats are managed during the assembly process, but also other formats like IP-exact, UPF for the power intent, SDC for the timing constraint, and physical design information like LEFDEF. This design solution has also checking capabilities like linting, coherency checks between different formats, but also this solution provides generation capabilities for RTL and for the design collaterals. Finally, this tool is fully compliant with mainstream RTL to GDS design flows. During the integration process, RTL and the power intent are jointly considered to help better manage turnaround time. So before logic synthesis, all the checks, all the generation, including promotion and demotion, are fully supported with many customization possibilities.
Finally, once everything is stitched correctly, the power intent is complete and consistent. Since we fixed all the issues created, you might want to change the UPF structures from what has been imported. Indeed, you've imported IPs with their own power intent information. On top of it, we created the top level in which we added additional information about the power intent, about the structure and the hierarchy. Additionally, some of the instances are now replicated in multiple physical partitions. So the power intent is somehow redundant towards those different instances, and it's split as well. So the tool offers the capability to manipulate UPF structure by changing the scopes. In one direction, there is the promotion, which consists in pushing upside the UPF information from the leaf scopes to the top level hierarchy. The reverse operation is called the demotion, where we are going to structure the UPF, the flat UPF, into subscopes like this. This process will definitely merge information if there is redundant rules or definition or power domains, and also split and propagate power intent information during the demotion. In this process, the power intent is preserved, equivalent views are generated. We rebuild all the power network, we rebuild the power domains, we regenerate level shifters, repeaters, isolation, and retention. We manage the power control signals, so we propagate correctly the right control signal names, even if they change throughout the different scopes. We manage power state tables, so they are merged or split depending on the cases. We regenerate boundary constraints for set port attributes. So this is mainly useful for the demotion process, where the scope is really intended to live as a standalone. So it's really important that all the ports are giving an attribute about what is the supply incoming from the outside, and we regenerate the glue logic. So this power intent management can be used in various cases. It can be used to export an IP from existing project. So let's say you have an old project where all the power were defined as a flat, but you would like to extract one of the IP and get all the information about it. So not only the RTL, but also the collateral view. So you can demote the information into B and get a package IP like this, B plus BUPF. You can also generate a flat UPF. This is typically our case in this scenario, where you have a top-level UPF file which you created and imported the UPF for certain IPs, and you want to have just a flat UPF for the full system. But once you have the flat UPF, you may also be interested in generating alternative power hierarchy, like regenerating subscopes for a physical partition, like in this case. So starting from the flat UPF and sub IPs like A, B, C, and D, you could also ask for the creation of X and Y UPF, which would represent physical partition. And this is really dedicated to an integration flow where you can even create more UPF information during the promotion. So the benefit of this promotion and demotion, or more generally the power intent management, is really to modify the existing structure of the UPF and make something different, which would match physical backends, or which can be used to extract IPs, make something more structured. It can help improve the readability and the debuggability of the UPF structure and the design. And the generated UPF is fully power equivalent. This step is definitely optional. You can stay with the initial structure, or you can decide to modify the structure to have a better readability, debuggability again, or enable new flows like parallel synthesis and so on.
For any complementary information about the Defacto's tool capabilities, please visit our website and don't hesitate to send us an email to info@defactotech.com. Thank you.